We can do a similar sort of thing for the potential energy for, say, a proton moving between 2 points near another proton. So 2-point charges near each other, and they're going to move. And in this case, I have chosen 2 protons. So the change in potential energy is going to be equal to negative integral QE dot ds, which in turn is going to be equal to negative Q integral E, and E in this case is 1 over 4 pi epsilon naught Q2, Q2, Q1, and we're going to move Q1 between 2 points A and B over R squared, R hat, dot the displacement. And here again, no matter what wacky path we use to go between the 2 points, the only thing that is going to survive is the summation of the components along the electric field, the unit vector for the electric field. So when we factor all of that out, we get negative Q1, Q2, 4 pi epsilon naught integral dr over r squared. This is a nice power rule, r to the minus 2. And therefore, the integral for that, Q2, 4 pi epsilon naught. I'll write the integration over on the side. Most of you are probably familiar with this one, but it may have been a few months or possibly even years since you've done it. So we add 1 and divide. So that would give us r to the minus 1 over minus 1, which would be equal to minus 1 over r. We plug that in, and we get minus 1 over r here. The 2 negative signs cancel. So we get, for 2-point charges, the change in potential energy is equal to 1 over 4 pi epsilon naught Q1, Q2 over R. 2 things to remember. 1, this is a scalar, so it has no direction. And if you indicate a direction for it, that is incorrect. Second thing to remember is that there is no squared here. This is r not squared. And we see the reason for that being r not squared when we look at this integration. But frequently what happens is you've been working with electric fields and electric forces now for a couple of weeks. And when you're thinking about point charges, the r squared in the denominator rolls off the tongue and even off the pencil almost automatically. So be very cautious about that as you move forward, and make sure that you get this